In this video, I'm going to do a quick demonstration of the stroboscopic effect. Now, what is the stroboscopic effect? If you have a rotating body, cyclically rotating, and you view it under flashes of light that have the same frequency as rotation, then the object appears stationary. So the chosen object here is this DVD motor, which comes with SEELab, and I've pasted the letters R and E on top of the spindle. The motor is connected to PV1. So if I change the voltage on PV1 via the software for the stroboscopic effect, which you will find under the school level menu here as stroboscope. So if I apply, let's say 1.2 volts, you can see that the motor is spinning. Now I have this LED here that's connected between SQ1 and ground, and I can make it flash briefly, okay? And it's also connected, the signal that's going to the LED, SQ1, is also connected to A1. So I can view it in the oscilloscope here. So right now the frequency is set to 1 Hertz, but the duty cycle is 0, which means the entire time is off. Let me increase the duty cycle to 50% to show you what 50% duty cycle looks like. So it's basically on half the time and off half the time, 50% of the time at 1 Hertz. What you need is a very small duty cycle, let's say 5%. So it has just briefly flash. Now we're going to increase this frequency till the letter R appears stationary. So I can use my keyboard keys after selecting a gauge and just use the arrow keys till that letter becomes static. There. So at about 23.09 Hertz, it just appears to be stationary. Let me increase the speed of rotation by increasing PV1's value about, let's say, 1.76. So it's spinning much faster. Now to match up with that, I need to increase this again, the flashing LED frequency, and at about 34.19, I can see that the letter is again stationary. So it's no magic, it's just that, the same time that this object takes one rotation is the time taken for the LED to flash a second time, and subsequently so on. So each flash is when the object is at one particular orientation. If I double this frequency from 34 to 68, again almost stationary, but I'm seeing this at 0 degrees and then at 180 degrees, and then 0 again and then 180. If you triple it, you will see at 120 degrees, so on. So if you see like this double pattern, you know that you should reduce by 2. Let's go back to 30, whatever it was. Now, if the object appears to be spinning forward, it means that you're at a lower frequency. You haven't caught up with the speed of rotation. So you should increase it till you match. And if you're over the frequency limit, it will spin backwards. Now, to explain the graph on the side, the frequency is basically the pulses per second. If I increase frequency, there are more pulses in the same unit of time. And duty cycle is the ratio of the on time to the entire duration. Now, as for these gauges, you can use your arrow keys to adjust, fine tune. You can also click on the center and set the exact frequency that you want. There's a small schematic diagram here, and yeah, that's about it for the stroboscopic effect. Thank you for listening.